This is a lesson on solving rational equations. So we're going to go through the steps. We're going to do examples together so you understand it. So the first step to solve a rational equation is to list the restrictions for the solution. The answer is that it cannot be. How you find the restrictions is the denominator, and you make it equal to 0. We know the denominator can't be 0. So if there's a value for x that makes the bottom 0, it can't be that answer. We write it down. Sometimes to do that, we're going to have to do this eventually. So this goes with step 1. We need to factor everything you can, every top, every bottom, factor everything you can so we can see everything clearly. Step 2 is we're going to make common denominators and then solve only the numerators. And then once you've solved it, make sure you have no extraneous solutions. Now that means a solution that is restricted from step 1. So if you find an answer that matches this restriction, we have to cross it out. It's extraneous, and what's left over is your solution. All right, let's practice this. All right, I want to solve this. Step 1 is to list the restrictions. So if I look at the denominator, 3x, make it equal to 0, and solve it, x cannot equal 0. There's no variable here, so if I make it equal to 0, there's nothing to solve. If I take 6x and make it equal to 0, divide, I get the same answer. So there is one restriction here. The only number x cannot be is 0. And now I want to solve it. There's nothing factorable, so the only thing I can do next is to make all the denominators the same. So how do I make them all the same? I'm going to take the first denominator and multiply top and bottom times 2. That's 6x. The next one, I'm going to multiply top and bottom times x. And then the last one already is the correct denominator. So now all the denominators are the same. At this step, only write down the numerators. So 2 times 1, 1 times x, and negative 1. And that's it. Solve that. So to get x by itself, add 1, and you just solved it. The answer is 3. Check. Is that a restricted solution? No. And so that's a good answer, and it's over. Those are the steps. Let's look at it again. This one will be a little bit more complicated, but not bad. All right, so if you need to, you can press pause and write that down, and we're going to do it together. So step 1 is to take the denominator on the side and make it equal to 0. And then to understand that, sometimes you just factor it and it becomes out. So if I look at the denominator, the two numbers that factor, so what two numbers multiply to 24 and add to negative 10? The next denominator is exactly the same. And then the last denominator is x subtract 4 by itself. Now look at the denominator. What is the 0 of this? What makes it 0? So I want you to notice that x cannot be positive 4. Because positive 4 take away 4 is 0. And 0 times anything will give me a 0 in the denominator, which is undefined. X can also not be 6. Because 6 take away 6 is 0. So if I look at each denominator, this one is 4. This one's 6. You can see those are the two answers that x cannot be. Those are your restrictions for the equation. The next step is to make the denominators all the same. Notice the first two denominators are already the same. This last one I need to make the same like the other ones. So I'm going to multiply top and bottom by x subtract 6. So now all the denominators are the same. At this step, you only write down the numerators. So I'm going to write down x plus 6. I'm going to write down negative 4. and then I have 2 times x minus 6. That's what I'm solving. So 6 take away 4 is 2. This is 2x minus 12. Combine like terms, so I'm going to subtract x and add 12. So 2 plus 12 is 14. 2 take away 1 is 1x, and you have your answer. Make sure that this is not one of the restricted answers. So x cannot be 4 or 6. That's a good solution, and it's over. Let's look at another example. Sometimes you end up with a quadratic equation. I'll change up the variable just for fun. So step 1, what can m not be? And recognize that m cannot be 0, because if m was 0, it would be undefined. Next step, we need to make the denominators the same. So we have 2m squared. I need to multiply it times 2, so it becomes 4, so they can match. So whatever I do the bottom, I need to do the top. This is 4m squared, so I need to multiply this by 4m, top and bottom. This way, by multiplying it by 4m, both of these will match. And then what does the last one need? I'm going to multiply by m squared, top and bottom, and now all the denominators are the same. Now write down only the numerators, and that's what we're going to solve. We're going to distribute. Notice our power term is m squared. It's a quadratic. So for a quadratic, we need to make it equal to 0. So 6 plus 4 is 10, but I need to subtract 10 to the other side. We're going to add 24, and then we're going to solve this by factoring. So the two numbers are negative 4 and negative 6. And so each factor has an answer. So the answer here is positive 4, and the answer here is positive 6. They don't equal 0, my restriction, so both are good solutions. Done. Let me give you another example. So in this situation, step 1 for me would be to factor this. So factor the denominator, and then factor out a 3, and then recognize what x cannot be. So x cannot be 0, and x cannot be positive 1. Both of those values, if you plug them in, would make it 0 in the denominator. We're now going to make common denominators. So I see 3x, x subtract 1. So all this needs is an x, top and bottom. But this needs the whole denominator. That's 3x, x minus 1, top and bottom. Now, all the denominators are the same. So only write the numerators. So I have 3x times x minus 1. I have 1, and I have x. And that's what I'm going to solve. So this is 3x squared minus 3x plus 1. And then I'm going to subtract x to both sides. At this step, it's a quadratic equation. I make sure it's equal to 0. I can actually solving this by guessing and checking. It's probably the quickest way. The only way you get 3x squared is by going 3x times x. The only way to get 1 is to go 1 times 1 because they're prime, and both of these numbers need to be negative. So we have negative x and negative 3. Together they make negative 4, so it's factored. If I look at the first factor, what's the 0 here? You add 1 and divide by 3. If I look at the second one, it's positive 1. At this step, we have to look at the restrictions. Are there any restrictions here that show up down here? And you can see that 1 needs to be crossed out. 1 is a restriction. That's called an extraneous solution. So the only solution that works here is 1/3. And 1 we cross out and we don't use at all. All right, that's solving rational equations. Till next time. Mr. G Math, over and out.